This problem is asking me to provide the vertex form, standard form, and intercept form of the given graph. The graph has a point at -4, -1, which happens to be the vertex. Given that the vertex is clear on this graph, it's best to use the vertex form of the equation. Y equals a times x minus h squared plus k. Knowing that the vertex gives me the points h, k, I can substitute those into the equation. But I still need to find this a value, so I need another point. The graph also gives me a nice clear point at -1, 2. So I can plug that in for x and y. Following PEMDAS, I'm going to solve the inside of my parentheses first. Then I want to get a alone. A equals 3/9, which is 1/3. So I can put that back into my original equation here for A, and I get the vertex form of my equation is y equals 1/3 x plus 4 squared minus 1. To find the standard form, I need to FOIL my trinomial here. Distribute my 1/3. And I'm going to rewrite this 1 as 3/3, so I have a common denominator with everything, so I can go ahead and combine my like terms and get x squared over 3 plus 8x over 3 plus 13 over 3 as my standard form. The other thing that I have to do now is solve for my intercept form. I notice that my intercepts are not nice points on my graph. So in order to find for my intercept form, I'm going to need to find those irrational but real roots. I'm already 60% of the way towards completing my square, so I'm going to continue with the completing the square process to find those irrational roots. So this shows me that my irrational roots are -4 plus root 3 and -4 minus root 3. And I can plug those into the intercept form. Y equals a x minus p x minus q. I know my a is 1/3 from my previous equations. X minus -4 plus root 3 times x minus -4 minus root 3. And distribute those negatives in. Y equals 1/3 x plus 4 minus root 3 times x plus 4 plus root 3. And that is my somewhat icky intercept form.